Question number 1 says, in terms of intermolecular forces, which of the following compounds is only capable of London dispersion? So we have different kinds of intermolecular forces possible. There could be molecules that do dipole-dipole interactions, for example, but one of these is only capable of London dispersion. In order to check out what's going on, we want to draw these molecules out so we can identify what kinds of bonds are present. CH3CH2OH, we've got that OH group there. CH3F, we've got that central carbon atom, and then we've got the F, and then we've got some hydrogens. So that's got that tetrahedral geometry. CH2CH2, that means that we have a double bond, because every carbon is going to have 4 bonds there. And then we have HBr. So what do we notice about the types of bonds that are present? In order for something to do dipole-dipole interactions, we have to have some bond dipoles. We need to have some polar bonds there. Can we find some polar bonds? Most of these do have polar bonds. So for example, on ethanol there, we've got an OH bond. This is partial minus, this is partial plus. So that is a polar bond, and that bond dipole is going to be able to interact with other bond dipoles to make dipole-dipole interactions. In this case, they're specifically hydrogen bonds. And then over here, we have a polar CF bond, right? This is also polarized towards the fluorine. The carbon is going to be partially positive. The fluorine is partially negative. The same thing with HBr. We've got a partially positive H, and we've got a partially minus bromine. And so those are examples of polar bonds that are going to be able to make electrostatic interactions with other polar bonds that will be dipole-dipole interactions or hydrogen bonds that are stronger interactions than London dispersion. However, over here, we don't have any of those. With CH2CH2, these are all nonpolar bonds. So carbon-carbon bonds are obviously nonpolar, completely nonpolar, and CH bonds, there's not enough of an electronegativity difference there to consider that a polar bond. So we would say that these are all nonpolar bonds, and therefore it is not able to do any dipole-dipole interactions or anything of that magnitude. We're going to say C right here. That is CH2CH2. That is the only molecule that is only capable of London dispersion.